Hello and welcome to this hopefully short tutorial on how to complete a blood flow simulation of the left coronary artery using labels. Um, the first thing you want to do is extract your files. You just right click 7-zip and then extract here, and then that will give you the NII files, and that's what you're going to be working with. Once you've extracted them, you want to load them up. So I've already put them in a separate folder, and I labeled it as 11 with the number itself because it's faster to label it as 11 compared to the 1208 5281 and remembering those numbers. So I'll just be using 11 to keep track of how many I've done, and so on and so forth. But without further ado, you pull them both in. You want to choose the label as a segmentation and the DIO as a volume. The reason being, without a volume background, you won't be able to do anything on the surface. And then with the label, you want to have that as a segmentation so that you can work with it. So volumes equal background, and segmentation equals like something you can work with. So pick label here and then show 3D. So you'll notice that sometimes it'll show like really far away, like way down like here, like it'll be like way down here or something, and uh, all you have to do is click up here to center it and that'll change the view. Really quickly, you can control left click to rotate with this axis, regular left click just to rotate all around, middle mouse to drag, and then zoom in and out. So the first thing we're going to do is click the segment editor up here. And then click this as your source volume. Like I said, if you don't have a source volume, it won't allow you to drag and drop or do anything. But let's focus on this. So since we're focused more on the LCA, we're going to get rid of the RCA really quickly. And how we do that is by clicking the scissors. You can keep all the settings the same, just default settings are fine, and you just want to drag all the way across to get rid of that right artery, and just like that it's gone. So now that we're here, we're going to follow through a couple steps. The first thing we have to do is kind of like clip the ends of this artery before passing it into SimVascular. Typically, if we didn't have a label, we would start to segment and everything, but that's a story for another video. Since we already have the label, we're just going to be working with them. So let's go on and export this by clicking this button. And if you're working in segmentation, just a quick little thing is you can change the opacity, but that's irrelevant. Let's go ahead and export this as an STL. So this is my number 11. So I'm going to put it inside this folder. I'm going to save them as STL and just click export. So we could have renamed the segmentation to anything. I didn't change it, so it just came out that way. But this is it. This is your STL. Okay. So next step, we can close all of this, discard. You want to go to pair view. Once in pair view, you want to click the little blue arrow button and go all the way to your STL that you just created. You could have labeled as renamed it as anything, but it doesn't matter. Once you've pulled it in, you want to click apply for it to show. And in here, we're going to be essentially clipping off the ends, and it's not a very simple process. Well, it's simple, but it's a very tedious process, and I wish I knew the ways of making this process less tedious, but we're working with what we have. So you want to click this icon while the label is selected. A lot of times you'll see stuff grayed out, and that's just because you might not have this selected. So once you have it selected, you can click that. The other way of getting to it is by clicking up here, so doing filters, and then alphabetical, and then clip. And you also have the option to add it to favorites. But let's focus on the clip. So the biggest thing is for the clip type, you want to choose box, because every other clip type is for very symmetrical models, and what we're working with is nowhere near symmetrical. Drag this box to fit the sort of shape that you need, and then similar to 3D Slicer, the middle click button, the middle scroller button to drag. This is where some of your 3D skills will come into play. You want to drag that and sort of click it, but not drag anything, just to make sure that it's lining up. The biggest thing with clipping is ensuring that this top line and the bottom line line up or are parallel to the surface that you're clipping. So let's have it like right here. You can see it's kind of like pretty symmetrical, so it's good enough. And then you can just hold that to make sure that it's good. Make sure it's not touching anything else, and uncheck the invert box and click apply, and that'll clip and remove that. You don't want to nest any more clippings, and you don't want to basically hide the existing. I know I did this a lot when I started. I didn't really understand how it worked, but each clip is going to be its own separate box. So again, while you have this selected, while you have the next clip selected, you clip again to keep the old clip intact. If you were to click the segmentation itself and then clip that, it wouldn't keep the other clip in mind. So again, box, uncheck invert, and then drag how you want the size to be. And then place it by dragging the plane to this. Now, I've noticed something pretty interesting. ParaView does not have a control scroll, control left mouse click like 3D Slicer, which is unfortunate, but there is a slight workaround so that you're not constantly changing your view and then rotating a little bit, changing your view and rotating a little bit. Is you want to grab maybe one surface, and this surface is where you'll use this surface as sort of a controller to getting the sort of thing that you want. So let's say, for example, I wanted the left side there to be parallel. I can just keep dragging the same surface around and around and around to make it to where I want it to be, like that. It's a whole lot faster than dragging it, changing your view, dragging and messing around with it like that. But let's check the perpendicularity real quick. So this box is a little big, but it's sort of not quite there, so I'm gonna just reduce the size a little bit, just so I have a little bit more. And you can see it's not quite perpendicular because there's a sort of twist right at the end. So I'm going to just drag it all the way up here to where I think it's perpendicular. Hold this button. Check the views. Make sure that it's good all the way around. Because like this, for example, it's not quite perpendicular here. At this view, it's not quite perpendicular. Notice how this line goes this way, and here it's like way up there, and this one is kind of like slanted down. So let me get some more precision on there and make this even smaller. So you can see now that like this line is not perpendicular. It's off to like a slight angle, and we're just gonna fix that real quick. So again, you can just drag one side of it and use that to make sure it fits whatever you want it to fit. So for me, I will drag this side here, and let's see if I can get this. Maybe another side of it like that. Yeah, this looks good to me. So again, I will just hold that, and yeah, this looks good. Could be better, but you know, perfection is not really the goal. It's to get as close as you can, but you don't want to waste too much time trying to get it super perfect. So yeah, that's done, but I don't really like it. I don't like how there's this sort of extra little place. So I'll spend some more time right now in case you might have something and you feel the same way. So I'll just drag it down a little bit more just to get rid of that corner. And let's reapply. And let's see what we got. That looks a lot better to me. And either way, this is an outlet, so the information at the outlet is not that crucial. But you might be wondering, why are we clipping in a software that has inferior maybe mouse rotation capabilities? 3D Slicer, although it has the better camera controls, it just doesn't have the same clipping functions. The only clipping function is the symmetrical one. So pair view is better because of that. Anyway, let's create another clip. Boom, invert, resize, and drag. This one looks like it's gonna fit right in. So it's looking really symmetrical right now, perpendicular, I mean, to the artery. So yeah, that looks good to me. Let's apply, and it has now removed that. So, oh, this one looks a bit weird. Let's go back and fix that. I didn't even notice that. But again, this is good for the purpose of this video. In case you run into things like this, then me running into that in the video is good, because I can show you how to fix those errors. You don't have to control Z or anything. You can just fix it. All right, let's do the test. All right, looks good. And then you just reapply. No need to control Z. If anything, control Z will set you back all the way to before you resized it. So 1, 2, 3 outlets are done. I think this is the final outlet, and then we'll do the inlet, and we'll be good to go. Make sure you're on the final clip. You don't want to, go back. Now you click another one, box, undo the invert, resize. There's no wrong or right way to do this. You just kind of have to get a feel for it. This one's a bit tricky because of how it ends, but if you just only pay attention to before any irregularities, so if you focus your attention on here and here, because if you were to move the box a little bit further out and trying to get like the corners, it would make your life a little bit more difficult. So I think this looks good. Let's do the test. Okay, drag around, test. Looks good to me. And apply. You want to have something that is perpendicular to your surface. You don't want to have something where it's like leaning forward. Like with all of these, they're not leaning forward at all. They're perpendicular to the surface. So let's create another clip. Box, undo the invert, and resize. Now we're going to do the inlet. Drag that down here. Again, making sure it's perpendicular to the surface. So let's pay close attention to the surface. If I cut it this way, I think it'll lean because it's not perpendicular. It's not quite perpendicular. It's sort of at an angle. And I'll show you what I mean. So let's clip it and then see how it looks. Okay, now it's looking pretty good. Never mind. Yeah, as long as the ends are in line, but you can see that like this, the top one is sort of leaning at about 190 degrees, whereas this is at like 170 degrees. You'd want it to be both at 190 degrees. So let's compare. So this is fine. It's not that big of a deal right now. It looks okay. But let's see if we were to do what I'm suggesting here. So I'm going to push that forward a little bit. Yeah. See that? How it's like leaning forward? You don't want that. So you want it more perpendicular. So this again, so it needs more. So let me do that. Let me push this a little bit more that way. Yeah, you really don't want something like this where it's at an angle. So now let's check in again. So now you can see that like this part is sort of leaning down and this part is also leaning down. I think I went a little bit too much, so I'm gonna just back it up a little bit. This looks good. This looks good to me. So let's put it in place. And it's not even like the previous part is deleted or anything. It's still there. I can just turn this back on to double check that, just like that. And you can see the difference already. So I'm going to turn that back off, hit apply, and now it's good. This looks a lot a lot better. It's perpendicular to the surface. Looks good. Oh, but there's a small part that's not included, so I'll just drag it a little bit to the right. And then apply again. Okay, perfect. Now that we're done, we're going to add another filter. So you can choose add filter, or you can click up here. I have it in my favorites, but I'll show you how to do it regularly. Is go through alphabetical, and then you want to click extract surface, and that will extract surface. Pretty much. You don't need to add any special settings, just hit apply. And one extra step you can do is to triangulate. Just to give it that extra bit of detail and sharpness. Anyway, now that we're done, you want to click the green arrow up here and save it. I'm going to save it as 11 clipped.stl. Click OK. Close. And now we can go on to SimVascular. So, excuse me. Now that we're in SimVascular, the first thing you want to do is create an SV project. I don't think you have to create a new project for each different model that you want to simulate. I don't think you do. I think you can have it all under one SV project, and as a matter of fact, I think that way would be even better. That way you can have multiple simulations, and you don't have to keep writing the parameters for the solver, which we'll get into later. So this is just to have the STL files. I'm going to create a new folder, and we'll call it SV project. And now I think it will be fine to have multiple models, multiple meshes, and multiple simulations under one. So we're going to first of all import the STL that we just created. The clipped. And we're going to call this model. Would you like to extract the faces? Absolutely. Separation angle, you can mess around with the setting, but 50 is okay. It's not going to show up, so you can do a reinitialization. This will be your wall. I'm going to call it 11 wall. You don't have to, but artery I think will be better. Yeah, artery. Make sure it's a wall, and this can be deleted. Now that you have this complete, you can save your SV project, fill hole with IDs. So now you will have all your holes filled, and you can start to label these according to your arteries. You don't necessarily have to, like, they're not crucial. It's like an optional thing, but you definitely need to have it labeled as a cap for all of the outlets or inlets. They all need to be caps. This is very important for later. And you want to make sure that they're all actually like responding to something that is on your model, as opposed to having something that's not actually on the model. Then you can just delete it if you don't see it. But yeah, these are all caps, and this is the actual inlet, so we'll call it inlet. Which one is this? Oh, okay. Let's see. So like I mentioned, there might be some that are irrelevant and need to be deleted, so I'll circle back to that one later. So for the sake of this video, I will label them accordingly, but again, this is completely optional. Okay, so this artery is the let me start with something that's easier. I'm not a medical expert. So this is the second from last. That's diagonal branch. Make sure that you do not have any spaces, because they will cause errors if you have spaces here. This looks like also, oh no, here it is, okay. So that is the first one that kind of runs down. I think that's the left marginal artery, or LMA. Okay. What is this one? That's the one all the way at the bottom. That's the LAD. So what is this one? I just want to be careful that I don't delete anything that actually is relevant. So this all forms part of the LCA, so I'll just label it LCA for right now. So we should have 1, 2, 3, 4, 5, and we have 1, 2, 3, 4, 5, 6. So excluding the wall, we should have that many caps. So 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. So yeah, this one is probably not useful. So anyway, once you've done that, you're good with the modeling. You can save it. Then next up, you want to create a mesh. I'm just going to call it mesh. And you can click the mesh tab up here. Same for modeling, it's this one, and then for simulation, it's that one up there. Meshing is pretty straightforward. Estimate and run mesher. This should take a little while. If it goes too fast, then you know something's wrong. Also, because I'm recording, it might take a little extra longer. I have a slightly older PC. Okay, this is great. You want to see this huge number of nodes, huge number of edges and faces. If you see something really small, then it didn't really mesh too well. Also, the blue covering the surface is a good indicator that it went well. Meshing is an underrated yet very important part of modeling. If you get your mesh correctly, you can expect to have no issues with the simulation. So let's continue. All right. So basic parameters, nothing really. Let's create a new simulation job. Just call it steady. Then for all your outlets, you want to put resistance of 1,000. Same here, resistance 1,000. All except your inlet. Your inlet, what we're going to do is right click, set BC, and then you're going to create a file called steadyflow.txt, as I'm about to show. And you're going to put these values in it. It doesn't matter where this file is, but click it, open it. Make sure you have those values right there. Again, 0, -65, 1, -65, like that. Click OK. Then move on to the next section. Keep this as rigid. Then for solver parameters, I'm going to go through this pretty quickly. So feel free to go back and keep the values that I use. So we're going to do 100 time steps. 0.001, 10, 4, 0.2, true, and then 0.001. These are just the most robust parameters. You don't want to have something that doesn't give you enough information, so this helps it get that little bit more detail out of your simulation. After the NS is 100, 1. Here we're going to pick 0.001 for the momentum equations on the tolerance. And then here 0.01 as well. Then 10 for the maximum number of iterations. Momentum loop 10 as well. 400, second order 0.5, 2, and 3. So we're good on that part. Select the mesh for the next part, and then you can create data files and use MPI if you have it. How to set that up is probably going to be another video or instructions in the thing, but using MPI is pretty good. So click create data files, and it's going to run in the background. This part usually takes a while, so this is probably where, oh, okay, so using MPI does a great job, I guess. Okay, this is awesome. Thank God for MPI. Okay, so once you've created the files, you can run simulation. This might be the part where, yeah, I will end the video, and then I will come back on another video and show you how to convert those results. But this is good for now. something you can do to make it run faster is put your settings to high performance. And I'm still figuring out, but there's probably a way to set higher GPU towards SimVascular. But because on Windows it's a .bat file that launches SimVascular, there's no way to add it in. But yeah, something along those lines. But yeah, this is it for now. Thank you.